Okay everyone, I wanted to record this video just to show you how to compute the one sample z-test. So this would be step 4 in the 8 steps that we've been practicing. So in order to solve for z, we need two formulas. So the first one is this one. Z represents the one sample z-test, and the x with the x bar over it represents the mean of the sample. And this symbol represents the mean of the population. And we need to subtract that and then divide by the standard error of the mean. So the standard error of the mean has its own formula, which is over here. See the standard error of the mean. This symbol represents the standard deviation for the population. And we're going to need to divide that by the square root of n, which you should recall n stands for the sample size. So here we have all the information provided that we need to solve for z. So we have the sample size, we have the sample mean, and we have the sample standard deviation, which we really actually don't need for this equation, but we do need the population standard deviation, the population mean, and the population size. So whenever we plug that into the formula, we'll start off by solving for the standard error of the mean. So for the standard error of the mean, we need the standard deviation for the population, which was 10.63, divided by the sample size, which was 35, the square root of 35. And so when we solve for that, we get a final value of 1.79. So our standard error of the mean is 1.79. When we plug those values into this formula, it looks like this. So we have our sample mean minus our population mean, 86.5, divided by the standard error of the mean, which was 1.79. And when we do that, voila, we have the final value here. So it's not a really difficult computation to make. It's actually quite easy once you try it a time or two. The last thing that I wanted to show you was in regards to the normal curve, the critical values, and when to reject and retain the null hypothesis. So this is our normal curve. Our critical value is 1.96 positive, negative 1.96. The reason it's either positive or negative 1.96, if you recall, because our hypothesis was non-directional, making it two-tailed. So that means it could have gone either way. If we were to actually plot this z-value here on this chart, it would probably be somewhere around, here we have our mean, right? 0 standard deviations away, and then we have 1 standard deviation away, and the 1.96 is just shy of 2 standard deviations away. So our 1.11 would be plotted somewhere around here. 1.11. And so this does not exceed our critical value, so therefore we should choose to retain the null hypothesis because that's the most attractive explanation. Let's just say, for example, that instead of these values, we had some other values and ended with a z-value of, let's say, 2.63. I'm just pulling numbers out of the air to kind of exemplify this for you. So if this is what we had gotten instead, 2.63, then this value would be found beyond our critical value, probably somewhere maybe right around here. And so if that was the case, then we would want to reject the null because our obtained value exceeds the critical value. So just to kind of review one more time, we have significant results when our obtained value is greater than our critical value. And when this occurs, we need to reject the null hypothesis. We have non-significant results when our obtained value is less than our critical value. And when that occurs, it's probably best to retain the null hypothesis. So this is going to be true going forward for every statistical test that we're going to be working with the rest of the semester. So that's why I'm kind of reviewing this, and I want to really kind of nail this into your brain, right? So that you don't forget or get confused. The critical values, on the other hand, those are going to be different depending on the type of statistical test that we're working with. And of course, I'll show you how to do that when we get to that point. But hopefully up till now, this is all making sense to you. I really hope it does. Please do not hesitate to reach out if you have any questions. So thank you for watching.